the recording. We got a lot of stuff to do today. But I want to talk about, the first thing I want to talk about is the next, or week 15. Week 15 is a long week. Yay. What does that mean? Down here, you can see that week number 15 deals with this week. So we have Monday, Tuesday, Wednesday, Thursday, Friday as week number 15. But we also have next week, Monday, Tuesday, and Wednesday. You don't have to turn in your stuff until next Wednesday. And it won't be marked late, which really doesn't make much difference anyways, does it? But what I'm trying to say, oh, this is not right here. It should be 10 to 11. This isn't right either. Do I have the wrong presentation in here today? Solving rational equations. I got the right one. Phew. No, but we do have a help session this week from 1 to 2. We do have our main lesson today from 10 to 11. I don't know why I have this one in here. But remember, and yeah, I must have copied Algebra 1's pace chart in there. Shame on me. All right. So, but what I'm saying is, if you understand this week's material and you finish, let's say you finish tomorrow, you're done with math for all until next year. When you think about it, because we don't come back until January 3rd, because we have the following week is vacation. We have our winter break. So that's something to focus on. You know, get your stuff done, especially before Wednesday when it's 62 degrees out. All right, so what are we going to do this week? We're dealing with solving rational equations, okay? We also have a Unit 4 final assessment this week, so there's really 3 things that you have to finish up this week, okay? You have to finish the 2 assessments and then that week 4 final, okay? Now, I'm not going to say this week is easy because some of you are going to struggle. There's no question that some of you are going to struggle with this week's material. Some of you are going to look at it and say, oh, that's really pretty easy. But let me show you what we're going to be dealing with. If I gave you an equation like this, let's say I gave you, I had one written down here. Hey, let's say I gave you this equation. Let's say I gave you, I thought I had this. Oh, no. I messed this up. Okay. Let's say I gave you 1/2 plus x over 3 is equal to 2x over 8. Would you know how to solve that? Okay. Maybe. Yes, because I watched the tutorial. Awesome. Now, this isn't one of the harder problems today, but the concept's the same thing. What we want to do is we want to multiply every single term by the lowest common denominator. How many terms are up there? How many terms are in this problem? 3. That's absolutely correct. So when we multiply by the lowest common denominator, we have to multiply every single term by that. This one, and this one. So the lowest common denominator in this problem is 24. I'm going to multiply this by 24. I'm going to multiply this by 24. And I'm going to multiply this by 24. And why am I doing that? Because look what happens here. If I divide this out, 24, 2 goes into 24 12 times, so that's 12, plus, and 3 and 24, that's 8, so that gives me 8x is equal to, and this is, that goes in there 3 times, so that gives me 3 times 2x, which is 6x. So now I have a new equation with no denominators. Which problem looks easier to solve, this one or this one? And let me remind you, they're both the same. They're the exact same equation. But this one I rewrote without any denominators. So that is what the whole thing this week deals with. If you can find the lowest common denominator and multiply every single term by that lowest common denominator, then it just becomes a regular equation to solve. That's it. And for some kids, you know, they might still struggle with solving that equation, but that's not Algebra 2. I mean, that part is like, well, man, that was back in Algebra 1, if you can't solve that. Okay, so that is our whole concept this week, is being able to solve a rational equation. How we're going to solve that rational equation? We're going to multiply everything by the lowest common denominator, because what does that do? It crosses out all of the denominators, and then it's just a regular equation to solve. Now, some of the equations that are going to be left over are not going to be easy. They're going to be quadratics in there. Oh no, quadratics. But we'll talk about those also. Now, there's something called an extraneous solution also. An extraneous solution is a solution of the equation derived from the original equation. So when you solve it, you get all these equations. Sometimes there's an extraneous one. What does that mean? It means it doesn't work. It means it would make the equation undefined. For example, if I had something like, let's say, and I'm not going to solve this equation, I'm just going to write out some crazy equation. Okay, not going to solve it. But I will tell you that if I solve this problem, let's say I solve this problem and I came up with the answers of -3, 2, and 7, okay? I can tell you right now that there are two extraneous solutions here, okay? This cannot be a solution. Why not? Because when I plug it back in here, -3 plus 3 is 0. 2 over 0 is undefined. That is not a solution that I could use. It's extraneous. Boom, throw it out. Also, 2. If I put 2 in here, 2 minus 2 is 0. You can't have a 0 in the denominator. That's an extraneous solution. Gone. So if I solved this problem and I came up with -3, 2, and 7, 7 is the only solution that would work, because it's not it doesn't make the function undefined. Okay? So you can tell what the extraneous solutions are before you even start the problem, because all you have to do is look at the bottom and just figure out what makes that equal to 0. Then that can't be a solution to the problem, because it would make it undefined. Okay, so that's what we're talking about. So you really want to check your answers over. Okay, so in this problem, if I solved it and came up with what number would be extraneous? What number could not work here? 0, right. If I came up with 0 as my solution, I would have to say, nah, can't work. Okay, but I'm sure the answer is not 0, so let's do this problem. What's my lowest common denominator in this problem? What am I going to multiply every single term by? X. It's exactly right. I'm going to multiply every single term by X. It's going to multiply 2 by this, this, and this. Okay, so now I'm left with 2x plus, well, these are going to cross out, 1 is equal to 4x. Oh, now it looks like a pretty easy problem to solve. I'm just going to subtract 2x from both sides. I end up with 1 is equal to 2x. I'm going to divide through by 2. X equals 1/2. Is 1/2 an extraneous solution? No. So I just leave it. So my solution to this problem is 1/2. Done. That's it. Now, are the problems going to get harder? Yeah. Is the practice going to get harder? Yeah. I think the practice is probably harder than the assessment is. There are some pretty tough problems on the practice this week. And problem number 1 is probably the hardest problem on the practice. I don't know why I did that, because it kind of messes kids up when they get a really hard problem like that. Okay. What's my lowest common denominator here? Now, I will tell you, I would factor. If I end up with a problem like this, I would factor. So I would rewrite this as 4 over x minus 2, x plus 2 is equal to 1 over x minus 2. Now, you know your lowest common denominator has to have both things in there, right? So my lowest common denominator in this problem is going to be x minus 2, x plus 2. So I'm going to multiply everything by x minus 2, x plus 2, x minus 2, x plus 2. Okay, then it's like, oh, that crosses out. Awesome. I'm left with 4 is equal to, oh, the x minus 2's cross out, x plus 2. Oh, my answer is x equals 2. Okay. Okay, somebody's saying, but what? What do you have a question on? Check it. Right. Could 2 be an answer? No, there's no solution here, right? Because we knew that if 2 was one of my solutions, it makes this undefined. There's no solutions in this problem. Okay. Very good for those of you that caught that. Excellent. Oh, no. Oh, it looks like a really hard problem, doesn't it? Okay. No? All right. I love that positive. So I'm going to, yes, I'm going to factor the bottom. Right. So I'm going to factor this to d minus 2, d plus 2. So my common denominator, or lowest common denominator, is d minus 2, d plus 2. So right away, I'm just going to multiply everything by d minus 2, d plus 2. And I do write this out so I know what's going on here. All right. D plus 2 crosses out. So I'm left with 2, d minus 2, plus here, the d minus 2 crosses out. So I'm left with 8, d plus 2 is equal to, oh, look at that. Both of them cross out. Excellent. Now, let's say you did that first step, okay? And you ended up with something in the denominator. Then you did something wrong, right? Because in every one of these problems, if the denominator doesn't cross out, you didn't multiply by the lowest common denominator, okay? Because that's what makes these problems awesome, is that they just cross off. So now I'm just going to multiply through here. So I get 2d minus 4 plus 8d plus 16 is equal to 14. I'm going to add my d's together. So I get 10d plus 12 is equal to 14. Subtract off 12. So 10d is equal to 2. D is equal to 2 over 10, or 1/5. That's your solution to this thing. 1/5. Crazy, isn't it? But could you imagine trying to solve this problem without getting rid of the denominators? Oh, would that be a tough problem to do? Now, could you do it? Sure. You can get a common denominator and work through that way, but geez, it would make it a whole lot harder. So the concept this week is multiply through by the lowest common denominator. Get rid of all the denominators, and then we should be able to solve it. Okay, so I'm going to put, oh, darn it, I've got the wrong presentation up here. I've got to get the Algebra 2 presentation here. 1 second here. Let's see here, Algebra 2, week number 15. Let's see here. I think this is right. Okay, so here is the presentation for this week. Put that in the thing here. And what I'm going to do is I'm going to share mine with you guys. Share application screen. Okay. Now I'm going to, oops, I forgot to tell it which one to use. I'm going to tell you right now that the first problem is one of the hardest. Okay. Do we want to skip number 1 and do some easier ones, or do we want to just jump in and do number 1? Jump in. All right. We're going to jump in. We're going to do number 1. All right. I'm going to take a deep breath here. What's my common denominator? Okay, we have 4 over x plus 4 over 2x plus 3 is equal to 9. What is my common denominator? Very good, Samantha. When in doubt, just use everything. Okay, that is my key to you guys. If you don't know what the lowest common denominator, use every denominator. It will work. Okay. All right. So I'm going to use 2x plus 3, and that is the lowest common denominator. So So I'm gonna write my problem out over here. Now, let's see here. Okay, so I've got 4 over x plus 4 over 2x plus 3 is equal to 9. I am going to use 4. No, I'm going to use, let me see what's the math I had. Yeah, okay. X, 2x plus 3. Okay, so that is correct. So I'm going to multiply everything by x. I'm going to change my color here so we can see what I'm doing. So I'm going to multiply everything by x, 2x plus 3, x, 2x plus 3, x, 2x plus 3. Okay, so here the x's cross out. Okay, that's cool. So I got 4, 2x plus 3, plus, and here the 2x plus 3's cross out. So I'm left with 4x is equal to, and here I'm just left with 9x, 2x plus 3. Okay, so I got rid of the denominator. But to tell you the truth, it still looks pretty tough, doesn't it? I mean, I'm looking at it, it's like, okay, this is distribute. Okay, good. I love it. So let's just jump right in. So I'm going to distribute. I'm going to get rid of the numbers in front of the parentheses. So this gives me 8x plus 12 plus 4x is equal to 18x squared plus 27x. Okay. What type of problem is it? Okay. It's a quadratic. In order to solve a quadratic, the first thing that should be going through your head is what? It's a quadratic. I must do what? Nope. Set it equal to 0. It has to be set equal to 0. You cannot solve a quadratic if it's not set equal to 0. So I have to get all my terms onto one side and the other side to be 0. That is key. And if that's not the first thing that's going through your head when you see a quadratic and you have to solve, change it. Make sure that's the first thing. So I'm going to add this. So this gives me 12x here. And this is 12. So I'm going to subtract 12x off. So I'm left with 0 is equal to 18x squared. I said I subtracted 12x off, right? Was that right? So that gives me 15x minus 12. Is that right? Okay. So got it down to a quadratic. What's my next step? Now we have to factor, right? But what is the first step of factoring? Always. Always, always, always. Okay, and it should be factor out the greatest common factor, if there is one. Okay, that should be the first thing. It's like, okay, I'm factoring. I'm going to factor out the greatest common factor. Why is it quadratic? Because the highest power is to the second. That is how I know it's quadratic, because x squared is the highest power. Now, if it was x to the third, it would be a cubic function. If it was x to the first, it would be a linear function. But since the highest power is x squared, it is a quadratic. And I know quadratics are to the second power. I know they have to be set equal to 0. And then the way to solve them usually turns out to be factoring, right? Factoring is usually the best way to solve. So what I'm going to do here is I'm going to factor out a 3. Okay, just a 3, because that's what's in common to all of them. So this gives me what? 6x squared plus 5x minus 4. All right. Whew. How are we going to solve this? As I said, this is probably one of the hardest problems on this practice. Factor more. What type of factoring do we have to use now? I call it something very specific. The cheater method. It's exactly right. There's a number in front of the x squared term other than 1. That means I have to use the cheater method to factor. Okay, I know how to factor using cheater method. I love the cheater method. I remember the cheater method. Remember, we have to use the first term. So this is going to be 6x here and 6x here. And remember, since we're cheating with the 6, we have to divide a 6 out at the very end. Then we multiply the two outer terms together. That gives me negative 12. What two numbers multiply? I'm sorry, 6 and negative 4 is not negative 12, it's negative 24. Okay. So what two numbers multiply to give me negative 24, but add up to 5? Well, 8 times negative 3. So I do positive 8 here, negative 3 here. Does 6 divide into either one of those parentheses evenly? No. So remember, we can break the 6 down. Anything that multiplies is 6. So I'm going to go 3 and 2. 3 times 2. So I'm going to divide a 2 out of this parenthesis here. I'm going to divide a 3 out of this one. So I'm left with 3x plus 4, 2x minus 1. Factored. Awesome. What are my solutions? 1/2 and negative 4/3. Woo! As I said, probably one of the hardest problems. Now, I look up at the top. Neither of my answers are up there. No. So, why aren't my answers up there? Read the directions. The directions say, what is the sum of all your solutions? Well, I have 2 solutions. I have to add them together now. Oh no, now I have to add? So I have to add negative 4/3 and 1/2 together. That means I have to get a common denominator. That common denominator is going to be 6. So this is going to be negative 8/6 plus 3/6, which is negative 5/6. Letter A. I said that this is probably the hardest problem on the practice. Could you, it's like, if you take a look at it, it's like, man, there's a lot of stuff in there. There's a lot of stuff, but all of the stuff we've worked on this year, right? I mean, we've worked on factoring, we've worked on, well, we really didn't work on adding fractions together, but I'm just assuming you guys know how to add fractions together. All right. Let's go to something a little bit easier. Let's go to problem number 2. All right. Problem number 2, it says find the solution set for the equation. This one, there's only 2 answers down at the bottom in the first place. But this one, what are you going to multiply all of your terms by? X minus 2. It's exactly right. This one's going to be a whole lot easier. I'm going to let you guys work on this one by yourselves, okay? And I'm going to take attendance real quick. And then we'll go through this problem. But it looks like it's probably going to end up being another quadratic again. So don't be worried. But remember, if it's a quadratic, you got to set it equal to 0. Nah, you could. Now, if the top crossed off with the bottom, that would make it a whole lot easier. But I'm not. Maybe it does. Oh, my goodness. It does. I never even thought about doing it that way. Wow. Yeah, and the next minus 2 is going to cross out. Oh my goodness. Looks like you're going to get the. I guess I'm not going to go do my attendance just of yet because it looks like you guys are going to have this one done in a hurry. Oh no, I'm looking. My Blackboard's not working too well. Okay, so let's say we factored this. Okay, so it does factor down to x minus 2, x minus 4, doesn't it? Over x minus 2. Look at that. So now I'm left with x minus 4 is equal to 5. If I add 4 to both sides, x equals 9. Now, could somebody tell me why letter B couldn't have been the right answer in the beginning? I mean, right away, 2 would equal 0, right? 2 is an extraneous solution. We knew 2 couldn't be an answer. So right away, we could have just crossed off letter B and said, hey, our answer has to be A, right? Because if the 2 is going to make it undefined. You guys are getting too smart. All right. Problem number 3. Since I didn't get to do my attendance yet, this just says how many solutions are there to the equation. Okay. Doesn't ask you to solve. Well, I think you should solve it just to get there, but that's what I would do. Okay. So Why don't you guys work on that? And I'm going to take attendance. Let's see here. Oh, no. Okay, attendance taken. B is the answer. All right, let's take a look. Now I know that if I work this problem out, okay, I know there's going to be some extraneous solutions. If I had -1 or +1, right? -1, +1 would be extraneous solutions because I have 2 over x plus 1 plus, and then I'm going to rewrite x squared minus 1 as x plus 1, x minus 1 is equal to 1. So I'm going to multiply every single term by x plus 1, x minus 1. And as I said, some kids are going to say, Mr. Shanklin, I don't need to do that. I can just cross things off. And yeah, you probably could. Nope, that's an x minus 1. So here, the x plus 1 is cross off. So I'm left with 2 x minus 1 plus both those cross off. So I'm just left with a 4 is equal to x plus 1, x minus 1, which I'm just going to rewrite as x squared minus 1. So if I multiply this through, I get 2x minus 2 plus 4 is equal to x squared minus 1. So this gives me 2x plus 2 equals x squared minus 1. It's a quadratic, so I'm going to rewrite it that way. So this gives me x squared minus 2x minus 3. If I factor it, -3 and +1, x minus 3, x plus 1. So my solutions are x equals 3 or x equals -1. But we already said that x equals -1 is an extraneous solution. So for those of you that said letter B, that there's only one answer, you are absolutely correct. Okay. You did it wrong, but you still got it right. Luck is on your side today. All right. Any questions up until now? Did you have a question, Allison? How did I get into quadratic form? All I did is I just moved the terms. So I had over on this side, I had x squared minus 1. So I just left it. And then I had 2x plus 2 over here. So all I did is I just moved the 2x over to this side, made it -2x right there. And then I subtracted the 2 off. So a -1 minus 2 gave me the 3. So that is where I wanted, anytime I have a quadratic, I want to make sure it's in standard form. So I've got an x squared plus something plus something. Yeah, because I always want to make one side equal to 0. And that means I just have to move the other stuff off. Now, if this was a negative x squared, I would have moved all this stuff over to this side. I always want my x squared to be positive. Okay, you don't want your x squared to be negative. That really causes some problems. Okay. All right, let's go to problem number 4. Find the solution set. Okay. Now, if I was doing this problem, and I look at it and it's like, oh man, I probably could factor this thing on top and bottom, but I'm just going to multiply everything by x squared minus 9, or I could break that down to x minus 3, x plus 3. So I'm just going to multiply. I just look at it and it's like, okay, I'm just going to multiply this by x squared minus 9. I'm going to multiply this one, x squared minus 9. This crosses off. I'm left with 3 minus x equals, I'm going to multiply the negative 3 through, so negative 3x squared plus 27. Now, this is a quadratic. Why is it a quadratic? This 2 right here tells me that. Now, this is negative, so I'm going to move everything to the left-hand side. I'm going to move this over to this side. I'm going to move this over to this side. Why? Because I want my x squared to be positive. So this is going to give me positive 3x squared. And then I still have that minus x on this side. And then I have negative 27 and positive 3, so that's going to be negative 24. So all I did is I just moved this stuff over to the side, and this is what I'm left with. Okay. Again, this is a cheater method for factoring because I have a number in front of the x squared term. So I'm going to factor this thing down to 3x, multiply across. So that gives me, what is 24 times 3? So it's 72, negative 72. Okay. What two numbers multiply into negative 72 but add up to negative 1? But it's negative 72, right? Negative 9 and 8. It's absolutely correct. So now I have minus 9 and positive 8. I cheated with a 3, so I have to divide a 3 out of one of the parentheses. So that gives me x minus 3, 3x plus 8. So my solutions are positive 3 or negative 8/3. Well, positive 3 is an extraneous solution. Why is it extraneous? Because if you put 3 in here, 3 squared minus 9 is 0. That cannot work. So negative 8/3 is the only solution that would work here. Why is it negative 8/3? Because when you factored it down, right? Once you have it factored down, then you set each of your parentheses equal to 0. So 3x plus 8 is equal to 0, or x minus 3 is equal to 0. Well, this one, I add 3 to both sides, I get x equals 3. Now, most of you don't do this. Most of you just do it in your head. It's like, what makes this equal to 0? 3 does. This one, I always remember it's just opposite of this over this. Well, if I subtract off 8, divide through by 3, I get 8/3. So once you're done factoring, you just have to set each one equal to 0, and that's your solution. Okay. Math is cool. All right, number 5. This one is not bad. I am going to let you guys work on this one. This one is one that you should be able to get to. As I said, the beginning ones started off pretty hard. This one, I think you guys should be able to do it. What are you going to multiply every single term by? What are you going to multiply? X plus 1. That's exactly right. Good. Was the previous one B or C? Let's take a look. Number 4, we had negative 8/3, so it should have been letter B. Letter B is the correct answer for that last one. All right, let's try number 5. Number 5, I'm going to multiply everything by x plus 1. Okay, and once you figure out what the lowest common denominator is, then it's like, okay, everything's gonna cross off on the bottom. So this is gonna be x plus 1, x plus 1, x plus 1. So that's going to cross off. I'm going to be left with 2x plus 1 plus, and then the x plus 1 is going to cross off. Did we do this problem already? This one looks very familiar. 9x squared plus 9x. Ah, another quadratic. No. All right, so I'm going to multiply through here. So that gives me 2x plus 2 plus 4x. I'm just going to add that together. So I got 6x plus 2 is equal to 9x squared plus 9x. It's a quadratic. So I'm going to bring this over to the side. I'm going to subtract 6x off, and I'm going to subtract off 2. So I'm going to be left with 9x squared plus 3x minus 2. Boy, the cheater method seems to be coming in really handy this week, isn't it? As an example problem. So now I have to use the cheater method again. So I'm going to multiply through. I'm going to do the cheater method over here. So I've got 9x. So I'm going to multiply the outer terms. So that gives me negative 18. What two numbers multiply to negative 18 but add up to 3? Is that 6 times negative 3? And since I cheated with a 9, I have to divide out a 9, but there's no way I'm going to divide a 9 out of those. So I'm going to do 3 times 3. So I'm going to divide a 3 out of this parenthesis and a 3 out of this one. So I'm left with 3x plus 2 and a 3x minus 1. So my solutions are negative 2/3 and 1/3. Oh no, my answers aren't up there. However, it says, what is the sum of the solutions? If I add negative 2/3 and 1/3 together, I get negative 1/3. Whew. That's some crazy practice problems this week. I feel sorry for the kids that did not come to this lesson and did not watch the recording, because it is not going to be easy to come up with those answers. They shall suffer. All right. Problem number 6. Not too bad. Now, that x to the 3rd minus 8, not going to be cool. I'm just looking at the way I would do this problem. I still think I would just multiply through to get rid of the denominators. I know I could factor this because it's a difference of cubes, but I'm just going to multiply through and see what happens if I just multiply through by negative or 2 minus x. 2 minus x. So that's going to cross out. So I'm left with x to the 3rd minus 8 is equal to negative 14 plus 7x. Oh, this one's going to be way harder than I thought. Oof. I'm not so sure I would do it that way. Find the sum of the solutions to the equation. Whew. All right, I'm gonna do it a different way. Somebody in the beginning of class said, can't we just simplify before we start? And now looking at it, I'm thinking I might do that. I know I can factor this to x minus 2 and then x squared plus 2x plus 4. Remember the factoring. Now, the 2 minus x, if I pull out a negative 1 there, I end up with this. Okay. If you pull out a negative 1. If you don't pull out a negative 1, you're just left with negative x plus 2, which is not the same thing as x minus 2. But if you factor out a -1, this is what you end up with. So that's what I did there. Why did I do that? I can cross that off now. That makes it a whole lot nicer. So now, what am I left with? I'm just left with -1 x squared plus 2x plus 4 is equal to -7. Okay, because this just crossed out. So now I'm back to a quadratic. I'm not a big fan of that -1, so I'm just going to divide through by -1. So I'm left with x squared plus 2x plus 4 is equal to 7. It's a quadratic. I'm going to subtract off 7 from both sides. So x squared plus 2x minus 3 is equal to 0. And now I can factor. So x plus 3, x minus 1. So my solutions are -3 or 1. Now, find the sum of the solutions. That looks like -2, right? If I add those two together. Now, I will guarantee you there will be nothing like that on the assessment this week. I did not put any cubes on there, so you don't have to know how to factor a cube. There's nothing like that. Most of them are fairly straightforward. And I'll show you what type of problems because at the very end of this practice, I put problems that, where am I think this one. So this one is very similar to something that you would see. Now, I will not ask you for the sum of the solutions. Go back, which one? The last one? Yep, it is B. Because it asks for the sum of the solutions, and our solutions were -3 and 1. Add them together, you end up with -2. All right. Number 7. Okay. What are we going to multiply every single term by? X plus 1 times x minus 1. That is absolutely correct. Oh, Samantha, you are absolutely, I did not look over to see the 2. You're absolutely correct. We need to multiply by 2 x minus 1, x plus 1. Now, if we didn't put the 2 in there, guess what? We'd still end up with we'd still end up with something that has a denominator. Okay? So you do have to, your lowest common denominator between all of those terms is going to be 2 x plus 1, x minus 1. Okay, because if you didn't put the 2 in there, that 2 is not going to cross off then. And that's where you have problems, because then now you still have a fraction in there. So if I'm going to do this problem, let me write it out. Get rid of that. So I have x minus 1 over x plus 1 plus 4 over x minus 1 is equal to 5 halves. Okay, so we said our common denominator was 2 x plus 1, x minus 1. This is going to take up a little space. 2x plus 1, x minus 1. And 2x plus 1, x minus 1. Okay. Now, I start crossing things off. So the x plus 1 is going to cross off the x plus 1. So what am I left with up here? Oh boy, this is not going to be nice. I've got 2 x minus 1, x minus 1, plus 4 times 2x plus 1, x minus, oh, that x minus 1 is going to cross off. So I've really got 8 x plus 1 and is equal to 5 x plus 1, x minus 1. Something doesn't seem right here. 1 second here. Okay. Whew, I'm looking at the problems that I have up here. All right, they're all right. Okay, so now, this is not, I should have even said number 1 was the hardest problem, because man, there's some hard problems on this assessment, or on this practice. The assessment is not even close to this hard. Okay, so in this problem here, I have to multiply through, I have to go x minus 1 here. Yeah, you definitely be prepared. So here, I have to multiply through, so this is going to give me, what is that going to give me? X squared minus 2x plus 1, and I still have the 2 out in front. This here is going to give me 8x plus 1, so that's going to be 8x plus 8 is equal to, so that's going to be x squared minus 1 here, so that's going to be 5x squared minus 5. This is crazy. So now I'm going to multiply through by 2 here, so that gives me 2x squared minus 4x plus 2 plus 8x plus 8. I sure hope I didn't make a mistake anywhere on the line here, because man, that would really mess us up. So that's going to be 4x here, and the 2 and the 8 is going to be a 10. So I'm left with 2x squared plus 4x plus 10 on the left side. On the right side, I'm left with 5x squared minus 5. It's quadratic, so I'm going to move everything over here to this side. Why? Because I want to keep my x squared positive. So that'll give me 3x squared minus 4x minus 15 is equal to 0. Just keep my fingers crossed I didn't make any multiplication mistakes in there. Okay, so now I have to factor this thing. So I'm going to do the cheater method. I'm going to do it on this side. So I've got 3x, negative 45. What two numbers multiply to give me negative 45, but add up to negative 4? I think negative 9 and 5 should work. So I cheated with a 3, so I have to divide a 3 out. So I got x minus 3, 3x plus 5. My solutions are 3 and negative 5/3. What is the sum? Of course, it's going to be what is the sum. So I've got 9/3 plus negative 5/3, which is 4/3. Whew. The answer's there. Thank goodness. Man. That was a tough problem. Well, because I have to add the fraction together, and in order to add a fraction or subtract a fraction, you have to have a common denominator, right? Well, 9/3 is 3, right? So that's why I did 9/3 plus negative 5/3, because I needed a common denominator. Right? I'm not making it improper. I'm just making a common denominator so I can add it together. Oh, man, I should have went through these practice problems before I gave it to you guys. Those are some major, major problems. Wow. Whew. All right, let's try number 8, because number 8 I can look at it and say this cannot be as hard. All right, number 8 I'm going to let you guys work on, because this one should not be that hard. Okay, so why don't you guys give number 8 a try, see what you get. I'm going to keep my fingers crossed. I mean, we just went through all of the hard ones. I think the rest of them are fairly easy. This one's number 8, right? Let me check. So number 8's okay. Number 9's going to, number 9 will cause a little bit of problems. Number 10, I think we did already. All right. We better hurry this up because we only have 10 minutes to go. All right. So what is my common denominator for number 8? What's the common denominator? what are you going to multiply everything by? Got it. X plus 1, x plus 2. Okay, so that is exactly what I'm going to do. I'm going to multiply everything by. So I've got negative 1 over x plus 1 is equal to 5 over x plus 2. So I'm going to multiply everything by x plus 1, x plus 2, x plus 1, yikes, x plus 2. So here the x plus 1's cross off, so I'm left with negative 1, x plus 2 is equal to 5, and then the x plus 2's are going to cross off, x plus 1. Multiply through, negative x plus negative 2 is equal to 5x plus 5. Yeah, it's the first time we had a problem that's not a quadratic. Yay. I'm going to add x to both sides. So I end up with negative 2 is equal to 6x plus 5. Subtract 5 off. So I'm left with 6x equals negative 7. X equals negative 7/6. No quadratics on that one. Whew, gotta like that. However, if we jump to number 9, looks like quadratics are coming back. What is my lowest common denominator? What is the lowest common denominator here? What am I going to multiply every single term by? And I'm going to factor this first. This factors to x plus 6, x minus 6. Okay? So what's my lowest common denominator? X plus 6, x minus 6. Very good. Or x squared minus 36. It's the same thing, right? So if I was going to do this problem, first thing I'm going to do is I'm just going to write the problem out. So I've got A. I'm going to go x plus 6, x minus 6. Plus 2 a minus 6 is equal to 1 over a plus 6. Okay, so I'm going to multiply every single thing by x plus 6, x minus 6. So x plus 6, x minus 6. X plus 6, x minus 6. Oops, I'm doing x's and they're supposed to be a's, but that's okay. We got the idea. So, lo and behold, they all cross off. I'm just left with a plus a minus 6 crosses out here. So I'm left with 2 a plus 6 is equal to, a plus 6 crosses out, a minus 6. Yay, no quadratics again. I love it. So now, I'm going to combine these. So that gives me 3a plus 12 is equal to a minus 6. Subtract off an a, so 2a plus 12 equals negative 6. Subtract off 12. 2a equals negative 18. A equals negative 9. Only one answer because it wasn't a quadratic. Yeah, and when they're not quadratics, they make it a whole lot easier to solve, right? So the answer should be letter A. That is absolutely correct. Whew. That was number 9, wasn't it? I was going to say we're running out of time here. So the last problem, I think this is the last one. Yep. Okay. So the last problem. What is my lowest common denominator? X plus 3, x minus 3. Or we could say x squared minus 9. That's perfectly fine to say that because it is the same thing, right? I did this one in the recording. Somebody watched the recording. So let's do it again. So if I looked at this one, I'm just going to rewrite this as 6 over, and I'm going to rewrite it as x minus 3, x plus 3, minus 1 over x minus 3, oops, is equal to 1. So I'm going to multiply everything by x minus 3, x plus 3. So x minus 3, x plus 3, x minus 3, x plus 3. This one, yeah, this one's going to be a quadratic. I can tell because this is nothing's crossing out here. So both of these cross out. So I'm left with 6 minus x plus 3. remember that minus sign. I'm going to put a -1 in front of here. So this becomes 6 plus negative x minus 3. So both these terms change. And then over here, I'm left with x squared minus 9, right? Because x minus 3 and x plus 3, so x squared minus 9. Quadratic. So I'm going to rewrite this as negative x plus 3. And then I'm going to move the x over, so that gives me x squared plus x minus 12. Two numbers that multiply negative 12 would add up to a 1. That's going to be 4 and negative 3. So x plus 4, x minus 3. So x equals negative 4, or x equals 3. Now, 3 is an extraneous solution. Right, excellent. So if 3 is an extraneous solution, the only solution here is negative 4. X minus 3, x plus 3, not factored. You're right, or factored. Elson, I'm not sure what you mean by that. X minus 3, x plus 3 on the top. You didn't get x squared at all? Well, you have to, and I'll show you why. Because here you have x squared minus 9, right? And x squared minus 9 factors to x plus 3, x minus 3, right? And that's what our common denominator was. So we multiplied every single term by that. Well, if you multiplied this term by x minus 3, x plus 3, which is x squared minus 9, don't you just end up with x squared minus 9 over on the side? And that's what I had there. I mean, I just multiplied it back together because I knew I couldn't leave x minus 3, x plus 3. It just, I mean, could you leave it? Sure, you could. But sooner or later, you're going to have to multiply it back together because you have to solve it. So you're going to end up with that x squared minus 9 multiplied back through. And that's where you're going to end up with it being a quadratic because it's an x squared. I knew that it was going to be a quadratic as soon as I saw that 1 there, and I knew I had to multiply everything by x squared minus 9 or x plus 3, x minus 3. It had to have been a quadratic. It just has to be. Oh, all right. So now you guys should have all the answers to the practice. I think the practice is way harder than the assessment. Once you are finished with your assessment this week, you are done for this year for Algebra 2, unless you're behind and you want to keep working on it. The Unit 4 assessment, right, yeah, you got to do the 2 assessments and then the Unit 4 assessment, right. The Unit 4 assessment is just multiple choice, it's just like a unit test, right. But once you're done with those, you are done for the week. Oh, I did have, wait. I did have one more slide that I got to get back to my slides. I got to get done. I got to stop sharing here. All right, I get back to my week 15 main lesson. Share now. Last slide. Yeah, there it is. Enjoy your winter break, because we don't come back until January 3rd. That's it. We don't come back until January 3rd. That is amazing. You guys have a great one. Bye.